You're looking live at the International Space Station Flight Control Room at the Johnson Space Center in Houston, and good day on this Tuesday, July 9th, 2013, as the Orbit 2 team of flight controllers has just completed a handover from the overnight shift, the Orbit 1 team, and is prepared to support the fourth spacewalk out of the International Space Station in the past 3 months, this time a U.S. spacewalk involving an American and an Italian astronaut. Chris Cassidy and Luca Parmitano, Cassidy of NASA, Parmitano of the European Space Agency, are suited up in the Quest airlock, ready to begin a planned 6.5-hour spacewalk. This, the first of 2 spacewalks over the next week, the next one a week from today. Spacewalk officers have described these 2 spacewalks as cats and dogs types of spacewalks, a variety of assembly, maintenance, and replacement tasks on the docket for today and for July 16th. The Orbit 2 team of flight controllers, as we mentioned a moment ago, has just completed a handover from the Orbit 1 team that has been presiding over spacewalk preparations throughout the course of the overnight hours. Today's flight director, who will be presiding over the spacewalk on the far right of your screen there in the white shirt, David Korth. He will be the lead flight director for both today's spacewalk and the one a week from today. He's taking a handover from Tony Sacacci, the Orbit 1 flight director, who 2 years ago today was presiding over the presentation of items at the mission management team meeting, the first mission management team meeting of the final shuttle flight in shuttle program history, STS-135. Sacacci was the entry flight director during STS-135, so a bit of history repeating itself. Sacacci on console today in the overnight hours as a space station flight director. And inside the Quest airlock, Karen Nyberg on the left side of your screen, assisted by Russian cosmonauts Fyodor Yurchikhin and Pavel Vinogradov as they begin to install safer units. Those are the backpacks, the simplified aid for EVA rescue backpacks on Parmitano first, who was in the equipment lock, suited up on the right side of your screen, and Chris Cassidy next will be receiving his safer backpack. These are jet-powered backpacks that would be used by crew members outside of the International Space Station during a spacewalk. In the highly unlikely event they would become untethered and would begin to float away, they could propel themselves back to the safety of the International Space Station. All of the spacewalk preparations have been going by the book extremely smoothly throughout the course of the overnight hours. Countdown clock here in the mission control room, counting backward toward the start of the depressurization of the crew lock section, the outermost section of the dual compartment Quest airlock. The go for depress is expected about 30 minutes from now, with the expected start of today's spacewalk around 7:10 a.m. Central Time, 8:10 Eastern Time. And by the rules of U.S.-based spacewalks, a U.S. spacewalk duration is measured from the time the crew puts its suits on internal battery power, their extra vehicular mobility units, until the time of repress at the end of a spacewalk. A Russian spacewalk duration is measured from hatch open to hatch closure. So we'll be following with the precise start time of today's spacewalk, which again is expected a little over an hour from now at 7:10 a.m. Central Time. As we mentioned, this is the fourth spacewalk out of the International Space Station in the past 3 months. 2 Russian spacewalks have been conducted already this year, and back on May 11th, Chris Cassidy conducted what had been an unscheduled spacewalk of 5.5 hours with Expedition 35 crew member Tom Marshburn to replace a leaking ammonia pump controller, if you recall, a spacewalk that was mounted in less than 36 hours from the time that the ammonia leak was detected on the truss of the International Space Station. Cassidy today will be conducting the 5th spacewalk of his career. His 4 previous spacewalks have totaled 23 hours and 35 minutes in duration. Cassidy designated today as EV1, or extravehicular crew member number 1. He'll be wearing the suit bearing the red stripes in today's spacewalk, as he will again a week from today. Luca Parmitano is conducting the first spacewalk of his career. A good shot of him on the equipment lock wall, the innermost section of the Quest airlock, where he was suited up a few hours ago. He and Cassidy conducted in-suit light exercise protocol, basically the flexing of arms and legs to increase the metabolic rate and provide an opportunity to begin to set the stage for the pre-breathing of pure oxygen in their suits to cleanse nitrogen out of their bloodstreams and alleviate any condition known as the bends or decompression sickness from occurring at the time that they step out into the vacuum of space. Parmitano's spacewalk today, historic in nature for the European Space Agency. This first spacewalk of his career marks the first time an Italian astronaut will have walked in space, and the first spacewalk by a European Space Agency astronaut since Hans Schlegel performed a 6-hour, 45-minute spacewalk with Rex Walheim on February 13, 2008, during the STS-122 mission of the shuttle Atlantis to the International Space Station that delivered to the complex the European Columbus module. As mentioned, today's spacewalk, a variety of different tasks. These tasks have either been spilling over from other spacewalks over the past several years, and this was the opportunity defined by the ISS Program Office to conduct a pair of spacewalks to clear the decks, some important replacement work of hardware, and the maintenance and assembly work to lay out cables in preparation for the launching and arrival of the Russian Nauka multipurpose laboratory module, a huge laboratory module that will also serve as a new docking port and spacewalk airlock for Russian spacewalks. That multipurpose laboratory module scheduled to be launched atop a Proton rocket from the Baikonur Cosmodrome at the end of the year. As you can see, Nyberg and Parmitano now guiding Chris Cassidy into the crew lock section of the Quest airlock, where he will await the arrival of Parmitano. After that, the crew will configure all of its tools, check out all of the airlock systems before the hatch is closed to begin the depressurization of the crew lock section of the Quest airlock about 26 minutes from now. Once the crew lock goes down to vacuum, there will be communications checks, final suit systems checks before the outer hatch is open to Quest, and the crew will place their suits on internal battery power to mark the official start of today's spacewalk. The International Space Station is currently flying at an altitude of 259 statute miles in an orbit inclined 51.6 degrees to either side of the equator, traveling from southwest to northeast, about to cross the equator over the South Pacific. The station, by the way, in the wee hours on Wednesday, will undergo a reboost and increase in its altitude as the Albert Einstein automated transfer vehicle will fire its thrusters for almost 10 minutes in duration, increasing the perigee of the station's orbit by almost 4 miles, and set up the correct altitude and phasing for the launch and single-day docking of the ISS Progress 52 cargo ship on Saturday, July 27th, as well as the correct phasing for the landing of the Expedition 36 crew on board the Soyuz TMA-08M spacecraft that is scheduled for September 11th, that will bring home Chris Cassidy, Pavel Vinogradov, and Alexander Mazurkin after almost 6 months in space. The docket of tasks for today's spacewalk will include the replacement of a controller box called a space-to-ground transmitter receiver controller that is housed on the Z1 truss on the zenith or top side of the Z1 truss, which is at the center point of the station's backbone atop the S0 truss of the International Space Station. That box failed in December of 2012, leaving the station's Ku-band high data rate communication system single string to a fault-tolerant failure capability. So that is the top priority of today's spacewalk, is the replacement of that transmitter receiver controller box to provide redundancy for the station's Ku-band communications system. Also on tap will be the retrieval of material science experiment packages out on the starboard truss of the International Space Station, called the MISSY 8, Materials for ISS Experiment, and an ORMATE experiment, which measures materials in low Earth orbit and how they respond to the station plowing through the low Earth atmosphere environment as it moves at a rate of about 5 miles per second. One of the critical tasks on tap for today will be the removal of a pair of radiator grapple bars that were delivered to the International Space Station on the last SpaceX mission of the Dragon cargo craft. Those radiator grapple bars are currently located on a payload orbital replacement unit attachment point on the mobile base system. A pair of those grapple bars, one by one, they will be removed and installed on both the starboard truss and the port truss of the International Space Station at the ready in the event of a radiator failure in the future that would require the replacement of a station radiator. Also on tap for the day will be the removal of a failed camera, a camera light and pan tilt assembly, as it is called, from the mobile base system on the International Space Station, the installation of a power cable for the multi-purpose laboratory module that, again, as we mentioned, will be launching to the International Space Station late this year, and the installation of jumper cables that in this today, the first of a two-part effort. The second and completing part of that installation effort will be a week from today. These jumper cables in the rat's nest, as it is known, of the Z1 truss of the International Space Station will provide a rapid bypass capability in the event of an electrical systems failure on the International Space Station in the future that would take down critical systems. This is a method of bypassing some of those system electrical paths to provide consistent power in the unlikely event of an electrical failure on the station. Finally, on the docket for today will be the installation of a cover on the docking port to which space shuttles used to link up, pressurized mating adapter number 2, which is at the forward end of the Harmony node, or node 2 as it is called. Pressurized mating adapter number 2 was the docking port for space shuttles in the past, and is now going to be protected from any micrometeoroid debris threat in the future, setting the stage for other commercial visiting vehicles and commercial crew vehicles to arrive at the International Space Station and dock to the same port that space shuttles used to dock to in the past. Now you see Luca Parmitano being gently guided into the crew lock of the International Space Station by Fyodor Yurchikhin. Karen Nyberg, once the crew has closed the hatch and they are set to go on internal battery power, will move from the Quest airlock to the robotics workstation in the Destiny laboratory of the International Space Station. She will be the robotics officer today, operating the Canadarm2, the big arm, from the Destiny robotics workstation, as she will be moving Luca Parmitano around in big sweeping moves as he moves from one work site to another with those large radiator grapple bars for their installation on both the starboard and port sides of the truss of the International Space Station. This is Mission Control Houston, a good view inside the Quest airlock. You're looking at Karen Nyberg, who is reporting on the progress of spacewalk preparations, joined by 3 Russian cosmonauts, Alexander Mazurkin in the foreground, joined by Pavel Vinogradov and Fyodor Yurchikhin, all spacewalk veterans of their own now, putting final checks on the systems with Parmitano and Cassidy stuffed inside the crew lock section of the Quest airlock. They will position themselves in their most comfortable and advantageous position. They're inside the crew lock section, along with several bags of tools and equipment that will be used to install new hardware on the outside of the International Space Station and to return failed hardware back inside at the conclusion of today's spacewalk that is scheduled to begin at around 7:10 Central Time, a spacewalk expected to last about 6.5 hours in duration. Cassidy and Parmitano have now been pre-breathing pure oxygen for about an hour and a half now, cleansing the nitrogen out of their bloodstreams, typical pre-spacewalk practice to alleviate any possibility of decompression sickness or the condition known as the bends as they make their way outside into the vacuum of space. The countdown clock here in the control room, about 16 minutes now until we should get the go for depressurization of the crew lock section of the Quest airlock, the precursor to the time that the crew would place their suits on internal battery power to mark the start of today's spacewalk. This will be the 170th spacewalk in support of space station assembly and maintenance, dating back to December 1998. And Nyberg now reporting back to spacecraft communicators Megan Bankin and Shane Kimbrough that the hatch is about to be closed on the Quest airlock. That will isolate Cassidy and Parmitano for the rest of the day and set the stage for the final pre-spacewalk preparations. Again, 170th spacewalk today in support of station assembly and maintenance dating back to December 1998. During the STS-88 mission, the first assembly flight of the station that joined the Unity module and the Zarya module together in the start of station assembly. In all, more than 1,067 hours of spacewalking time have been accrued to date. That's the equivalent of some 44.5 days of spacewalk activity in support of station activities. Yurchikhin now ratcheting the intravehicular hatch, as it is called, closed. That will isolate the crew lock from the equipment lock and set the stage for the depressurization of the outer portion of the Quest airlock, which is the crew lock inside which Cassidy and Parmitano are now located.
Houston Station, the IV hatch is closed, the equalization valve is off, and the emergency MPAV is closed.
Karen, we copy all.
Confirmation that the hatch is now closed and latched.
Left on the pre-breathe clock.
Karen, we copy.
Megan Bankin, who is the Capcom on console today, will be primarily talking to Nyberg regarding station systems and robotics work throughout the course of the day. It was Bankin, formerly known as Megan MacArthur, who flew on the STS-125 mission. That was the final servicing mission to the Hubble Space Telescope several years ago. She was the robotics officer who grappled and released for the final time the Hubble Space Telescope. Shane Kimbrough, veteran spacewalker, who conducted a pair of spacewalks on the STS-126 mission in November of 2008. Kimbrough will be talking to Cassidy and Parmitano as the ground-based intravehicular crew member, or spacewalk choreographer, if you will, throughout the course of the day. Kimbrough at the top of your screen, Bankin to his left, and then you see David Korth and Greg Whitney, another flight director who has joined Korth on console for today's activities. One item that you'll be seeing throughout the course of the day, the use of helmet cameras for both Cassidy and Parmitano to provide up-close and personal views over their shoulders, basically, of the work that they'll be doing outside the International Space Station. Each helmet camera has its own designated number. Chris Cassidy, as extravehicular crew member number 1, wearing the suit bearing the red stripes, will have helmet camera number 20. Luca Parmitano's helmet camera will carry the number 17. You'll see those numbers ghosted in the lower right-hand corner of your screen when those helmet camera views are made available to us throughout the course of the spacewalk today. The depressurization of the outermost section of the Quest airlock, known as the crew lock, inside which Chris Cassidy and Luca Parmitano are suited up, are ready to begin today's spacewalk. That depressurization of that compartment is expected to begin about 8 minutes from now. The International Space Station, flying at an altitude of 259 statute miles, is moving from southwest to northeast, approaching the Central American coastline. It will cross Central America into the Caribbean Sea, fly directly over Havana, out over the eastern Gulf of Mexico, and just almost directly over the Kennedy Space Center a short time from now. This is Mission Control Houston. You're looking at a view of the International Space Station Flight Control Room, where everything is set for today's spacewalk, known as US EVA 22, the first of two U.S.-based spacewalks in as many weeks, the next one a week from today. Chris Cassidy and Luca Parmitano suited up in their extravehicular mobility units, the EMUs as they are known. They are all set to begin their depressurization of the crew lock section of the Quest airlock less than 3 minutes from now.
Houston Station on Space Ground 1.
Go ahead, Karen, on 1.
Yeah, my pre-breathe timer has ended. Just wondering if you guys are ready to continue.
Karen, Houston is go to continue.
Okay, we'll pick up in step 49 and then continue on to the cue card.
We copy and concur, Karen.
So, Luca, first, can you confirm that the depressed pump power is off on the UIA? Copy that. On your DCMs, check that your comm frequency is low and comm mode is PRI. Complete.
PRI low. EV2, PRI low.
Luca, on the UIA, take the depressed pump power to on.
On the count of 3, 2, 1, on.
Luca, take the depressed pump manual isolation valve to open. You guys can expect an alert tone.
Okay. The manual isolation valve is open.
Monitor your suit pressure gauge that you're less than 5.5.
Copy.
You can expect an alert at 6.0 for the crew lock pressure. When you get to 5.0, Luca, you need to close the depressed pump manual isolation valve at 5.0.
Copy. And that's for the airlock pressure?
That's the airlock pressure, yes.
The airlock pressure at 5.0, I will close the depressed pump manual isolation valve.
Copy.
This is Mission Control Houston. The depressurization of the crew lock of the Quest airlock of the International Space Station now underway. It will occur in a two-step fashion, taking the pressure in the crew lock down to about 5 pounds per square inch, at which point we'll take a pause for a systems and suit check for both Chris Cassidy and Luca Parmitano before the resumption of that depressurization is conducted to take the crew lock down to vacuum. Here in the flight control room, a key figure in today's activities is Spacewalk Officer Ernie Bell, that you see there in your view at the EVA or Spacewalk console, right behind the flight director here in Mission Control. Ernie Bell recently narrated a feature in which he laid out the tasks for today's spacewalk, known as US EVA 22. Let's take a look at that feature.
We'll start out EVA 22. Chris is going to be wearing the red stripes. He's going to be egressing first, and he's going to do so with a spare space-to-ground transmitter receiver controller. Luca Parmitano, then, he's going to be wearing the plane suit, will egress second, and he'll take with him a cover for one of the Missy experiments, the Ormate. So the first task for Chris, he'll translate aft on the airlock and up to the top of Z1, and he's going to get in position to replace the failed SGTRC. So he'll first stow the bag with the replacement SGTRC on top of the Z1 truss. He'll set up a temporary hardware stanchion, which he'll then attach the spare SGTRC to. So he retrieves it and places it on top. He'll then move over to the failed unit and get in position to release it via 3 bolts. Here you actually see a picture of Chris in the neutral buoyancy lab practicing this actual procedure. Once he's removed the failed one, he'll grab the spare and install it into the same location. And once complete, he'll stow the failed inside the bag, place the hardware stanchion inside the bag, and close it up. Once complete with the task, he'll return to the airlock where he'll stow this entire bag inside. Now, while Chris has been working on the SGTRC, Luca has translated up the CETA spur to outboard side starboard truss to the Express Logistics Carrier number 2, where the Missy experiment is located. This actually includes 2 items, the optical reflector materials experiment, or the Ormate, and the payload experiment container, the PEC. So he'll get up onto position there on the forward zenith side of ELC2. And first thing he'll do is take some pictures of the material experiment. He'll also look over at inboard and take some photos of the AMS. Put a cover on the Ormate, remove it, and place it on his mini workstation. He'll then close the PEC, where the experiment was actually inside of it now. And here's a photo of the experiment on orbit, so you can see the hardware. He'll demate 2 cables from the PEC and connect them to the base. At this point, he'll release the PEC payload and stow it on his body restraint tether and translate back to the airlock. At the airlock, he'll actually stow both the Ormate and the PEC inside, and we can expect both the crew to be back at the airlock together at about this time. They'll then begin their next task, which is a starboard radiator grapple bar install. For this, Chris will translate up to the starboard CETA cart with a large RU bag that he's going to use for some flight support equipment brackets that he'll later remove from the RGBs. So he'll place this bag on the CETA cart. He's going to actually take out a large or a handling device, go up onto the mobile base system, and place this handling fixture or scoop onto the mass camera. This is for use later by Luca. He'll then go back to the SETA cart. Meanwhile, Luca has been retrieving a foot restraint. He'll actually gather this from the forward side of the external stowaways platform number 2. He'll put on his BRT and then translate out port, just slightly port of where Chris has been working, where he'll begin steps to ingress the arm. So once he's on location, he'll put the foot restraint at the end of the arm, and then he'll ingress the foot restraint. At which point Karen is going to fly him over and get him in position where he'll be able to take control of the first of 2 RGBs. Meanwhile, Chris is moving around, breaking torque on the 4 bolts that hold this first RGB to the second one. On the forward side there, you see him. He'll release 2 bolts, translate around onto the second RGB, and then move back inboard so that Luca can move into position to take control of this first RGB. Once Luca takes control of it, Chris will release the second 2 bolts. Karen will fly Luca out, and Luca will then reposition the RGB into a better attitude for installation over on the starboard thermal radiator rotary joint, or the targe. And this arm maneuver here is going to be about a 15-minute maneuver. So he'll fly up over the station and get into position. Now during this maneuver, Chris is actually going to remove the 2 flight support equipment brackets that were used to hold the 2 RGBs together. He'll stow them back in the large ORU bag, which is over there on the SETA cart. So there's the first one, and now working on the second one. Once he has those both removed, he's going to translate outboard on the starboard side of the truss, and he'll meet up with Luca for the installation of this first RGB. So once in position, the 2 of them will work together to align the RGB on the stow bolts, on the stow beams. See there, and then they will iteratively work back and forth to secure the 2 bolts to mount that to the targe. Here's a photo from the neutral buoyancy lab of this task taking place. Once complete, Luke will be flown back towards the second RGB, which is still located at the POA. During the maneuver, Chris is actually going to translate back towards the airlock. And once he gets down to the airlock, he'll translate to the zenith forward high pressure gas tank. And here he'll retrieve the MLM power cable. This was previously staged there by Sonny Williams on EVA 18. The task here is to route the cable along the starboard side of node 1 and onto the PMA 1, or pressurized mating adapter number 1, on the aft side of node 1. Once Chris gets this task complete, he's going to translate back towards the port SETA cart, where he was earlier, to help with the release of the second RGB from the POA. But first, Luca, on the flight over to the second RGB, is going to be brought in to remove a failed mass camera on the MBS. He'll drive a single bolt. That'll release that camera, and then Karen will fly him away, and the rest of the way over to the second RGB. And once he's in position, he'll actually hand the camera off to Chris. Chris will then retreat aft near the SETA cart. Luca will take control of the RGB. Chris will help work clearances, and they'll fly him out away from the POA. Again, Luca will rotate the RGB for the installation, this time over on the port targe. In This flight here is actually about a 27-minute maneuver, so it's a pretty long arm maneuver. So there is, again, some time for Chris to go and work some other tasks. During this flight, then, Chris will return to the airlock, drop off the failed camera, grab two bags, one being a PMA-2 cover bag and the other a crew lock bag. We'll translate out to the forward end of the station where PMA-2 is and drop off the PMA-2 cover bag. He's not going to install the cover yet, but he will stage the bag. At this point, he's going to begin translating back to the port targe. Along the way, he'll drop off his crew lock bag. It's for use later with the Z1 Y bypass cable task. We'll translate the rest of the way out to the port targe. And timing working out, Luca will be arriving right around this time. So they'll again work together to stow this RGB in the same fashion that they did the first one. They'll work to align it onto the stow beams and then take turns iteratively driving the two bolts to secure it to the targe beam. At this point, Luca will be flown back to the same location where he ingressed the arm. It's about a 13-minute maneuver. Be a slightly different orientation, but essentially the same location. He'll egress the foot restraint and then remove the foot restraint from the arm and take it back down to ESP2 where he retrieved it from earlier in the EVA. At this point, Chris has translated back, picked up his crew lock bag, and is heading around to the aft side of Node 1 to a bag there called auxiliary bag number 1, where he's going to retrieve the two cables for the Z1 Y bypass task. So retrieve those two cables and translate up over the top of Node 1 to the port side of the Z1 truss segment. Once he gets onto work site, first thing he's going to need to do is to reorient a foot restraint out of the way, and then he'll stage his crew lock bag. There's just a few tools and caps and such for the cable task. And then he will work the cable installs. He'll actually do a complete install of the Nader cable or the 4 Bravo cable. He'll do a partial install of the 3 Bravo cable or the Zenith one. That one's actually going to be completed on EVA 23. At this point, he returns to the airlock and stows the crew lock bag. At this point is another sync point for the crew where they'll both translate forward on station out to the PMA-2 location, where they'll work in conjunction to install the PMA-2 cover around the forward end of the PMA-2. There's basically a number of Velcro straps that they're going to cinch down onto the handrails around the circumference. One of the crew members then will pick up the PMA-2 cover bag, translate back to the airlock. This bag will be stowed inside the airlock and brought inside at ingress. The other crew member is actually going to translate back to the port CETA cart where the large RU bag, which contains those FSE brackets, is going to pick up that bag and then take it down to the airlock. Now this bag actually won't be brought inside on this EVA. The airlock's getting pretty full, so instead the crew is going to stow it on the starboard end there of the airlock. See right there where the handrails are flashing, and now place the bag there. Once it's complete, Luca will ingress first, Chris will ingress second, close the hatch, and this will complete the EVA-2 tasks.
Ernie Bell, today's spacewalk officer here in Mission Control, providing a detailed narrative in that feature on all of the tasks that lie ahead over the next 6.5 hours for Chris Cassidy and Luca Parmitano. They are inside the crew lock section of the Quest airlock. You're looking at Karen Nyberg across the hatchway from the two spacewalkers in the equipment lock section of Quest. The two crew members have just conducted leak checks on their suits. All of their systems on their extravehicular mobility units are ready to support today's spacewalk, the 170th, in support of space station assembly and maintenance. The depressurization of the crew lock continues. We're at about 2 pounds per square inch of pressure. Everything appears to be on track for an on-time start of the spacewalk at around 7:10 Central Time this morning. The marking of the demarcation point of the start of the spacewalk comes at the time that Cassidy and Parmitano place their suits on internal battery power. The end of a U.S.-based spacewalk is marked by the repressurization of the crew lock at the completion of today's spacewalk activity. As mentioned earlier, today's spacewalk, the first of 2 in as many weeks for Cassidy and Parmitano, marks the onset of an extremely busy time aboard the International Space Station. In addition to ongoing scientific research, next week, again, the second of these 2 spacewalks by Cassidy and Parmitano, and in 2 weeks, the departure of the ISS Progress 50 cargo ship that has been at the space station for the past several months, and the launch and docking of the ISS Progress 52 craft that will carry up almost 3 tons of supplies, and actually will also be used for the deorbiting of the Piers docking compartment, to which it will link up to on July 27th. It will remain docked to Piers for the duration of its stay, and then be used as the method, the propulsion method by which the Piers docking compartment will be deorbited for a destructive entry back into the Pacific Ocean just before the arrival of the multi-purpose laboratory module.
DPDT gets close to 0, you can expect an alert tone. And Chris, for you, when the EV hatch delta P is less than 0.5, you can open the hatch.
At 0.5, open the hatch. So, Luke, I'm going to take a second to talk about our tethers here. I'll start with structure, which is the airlock D-ring extender. On it, we have your right waist tether. The gate is closed. The locking mechanism is locked. It goes back to your crew hook. Excuse my pulling. That hook is closed and locked on your right D-ring extender. The load then goes through your suit, the other extender on it. I see your red hook. You can see it too. That's closed and locked. Your load alleviating strap goes to a red Ircum body, which is in the unlocked position. Coming out of it, you have the white anchor hook. That has a closed gate and a locked mechanism onto the green Ircum body, which is in the unlocked position. The green crew hook goes back to the other Ircum body. It's closed and its locked position is not important to our safety load path. Coming out of the Ircum body, the green Ircum body, you have a blank hook. That is gate closed, slider locked on my right D-ring extender. Also on my right D-ring extender is my waist tether. The load goes through my suit. And there you go. There you have it. That's complete. I'm going to look at my tether pack for once we transition. On my left D-ring extender, I have a closed gate and a locked mechanism. Unlocked Ircum body, white hook. Going to the other Ircum body, the white hook is gate closed and locked. This Ircum body is in unlocked position, and my green hook is back onto the red Ircum body. My blank anchor hook is standing by on my mini workstation, ready to transition to the aft airlock. Let's see, one other thing to check. I am BRT'd and redded to the SGTRC bag. That will come out with me. Luca, if you concur, we'll tag up with Shane in a little bit, but I think our tethers are in a great configuration.
I concur, and I copy and I followed you, and I checked the same status.
Roger that. I still have a green light.
Chris Cassidy reviewing tether configuration and tool configuration with Luca Parmitano, his spacewalking mate, for today's activities. Cassidy as extravehicular crew member number 1, wearing the suit with the red stripes, about to embark on the 5th spacewalk of his career. Luca Parmitano is about to undertake the first spacewalk of his career, the first Italian astronaut to walk in space. The crew lock steadily heading down to vacuum, at which point a final systems check and communications check will be conducted by Cassidy and Parmitano before the outer hatches open, the precursor to the crew placing their suits on internal battery power that will mark the official start of today's excursion. As you saw in the feature narrated by Spacewalk Officer Ernie Bell, Cassidy will be first to emerge from the Quest airlock. He will take out the space-to-ground transmitter receiver bag. That controller will replace a failed component on the zenith side, or the top side of the Z1 truss at the center portion of the backbone of the International Space Station, to replace a failed space-to-ground transmitter receiver controller box that ceased operation in December of 2012 and left the station's KU-band high data rate communication system as single-string fault tolerant. Once Cassidy is outside, having attached himself to various tether points outside of Quest, he'll give the go for Parmitano to join him outside. Parmitano will be exiting with equipment that will be associated with his first work of the day, which will be a transit over to the far starboard side of the station's truss to retrieve a pair of material science experiments called the Missy 8 and the Ormate experiment that were deployed during the STS-134 and 135 missions 2 years ago.
Got to get it clear of the hatch path. Okay, good, thanks. Almost there, 0.6.
Cassidy conducted 3 previous spacewalks on the STS-127 mission in July of 2009 that conducted a variety of critical replacement work for components of the International Space Station. His fourth spacewalk occurring on May 11th, an emergency response to a leaking ammonia pump controller on the truss of the International Space Station, a 5.5-hour spacewalk just 2 months ago with Tom Marshburn of the Expedition 35 crew. The crew now reporting that the outer hatch to the Quest airlock is open.
Get my visor.
Is it okay, Chris, with the back?
Let's see, I need to come back to you a little bit. Hold on.
With the outer hatch open, taking a look at the KU band downlink television predictions, we are not expected to resume a television capability for about another 19 minutes or so. We'll keep you posted on that. But the outer hatch is open, and we're standing by for final systems checks before the crew begins the official start of today's spacewalk.
Tell me if I can help you.
From the time the crew puts its suits on internal battery power, their extra vehicular mobility units, until the time of repress at the end of a spacewalk. A Russian spacewalk duration is measured from hatch open to hatch closure. So we'll be following with the precise start time of today's spacewalk, which again is expected a little over an hour from now at 7:10 a.m. Central Time. As we mentioned, this is the fourth spacewalk out of the International Space Station in the past 3 months. 2 Russian spacewalks have been conducted already this year, and back on May 11th, Chris Cassidy conducted what had been an unscheduled spacewalk of 5.5 hours with Expedition 35 crew member Tom Marshburn to replace a leaking ammonia pump controller, if you recall, a spacewalk that was mounted in less than 36 hours from the time that the ammonia leak was detected on the truss of the International Space Station. Cassidy today will be conducting the 5th spacewalk of his career. His 4 previous spacewalks have totaled 23 hours and 35 minutes in duration. Cassidy designated today as EV1, or extravehicular crew member units. Those are the backpacks, the simplified aid for EVA rescue backpacks on Parmitano first, who was in the equipment lock, suited up on the right side of your screen. And Chris Cassidy next will be receiving his safer backpack. These are jet-powered backpacks that would be used by crew members outside of the International Space Station during a spacewalk. In the highly unlikely event they would become untethered and would begin to float away, they could propel themselves back to the safety of the International Space Station. All of the spacewalk preparations have been going by the book extremely smoothly throughout the course of the overnight hours. Countdown clock here in the mission control room, counting backward toward the start of the depressurization of the crew lock section, the outermost section of the dual compartment Quest airlock. The go for depress is expected about 30 minutes from now, with the expected start of today's spacewalk around 7:10 a.m. Central Time, 8:10 Eastern Time. And by the rules of U.S.-based spacewalks, a U.S. spacewalk duration is measured. You're looking live at the International Space Station Flight Control Room at the Johnson Space Center in Houston, and good day on this Tuesday, July 9th, 2013, as the Orbit 2 team of flight controllers has just completed a handover from the overnight shift, the Orbit 1 team, and is prepared to support the 4th spacewalk out of the International Space Station in the past 3 months, this time a U.S. spacewalk involving an American and an Italian astronaut. Chris Cassidy and Luca Parmitano, Cassidy of NASA, Parmitano Parmitano of the European Space Agency are suited up in the Quest airlock, ready to begin a planned 6.5-hour spacewalk. This, the first of 2 spacewalks over the next week, the next one a week from today. Spacewalk officers have described these 2 spacewalks as cats and dogs types of spacewalks, a variety of assembly, maintenance, and replacement tasks on the docket for today and for July 16th. The Orbit 2 team of flight controllers, as we mentioned a moment ago, has just completed a handover from the Orbit 1 team that has been presiding over spacewalk preparations throughout the course of the overnight hours. Today's flight director, who will be presiding over the spacewalk on the far right of your screen there in the white shirt, David Korth. He will be the lead flight director for both today's spacewalk and the one a week from today. He's taking a handover from Tony Sakachi, the Orbit 1 flight director, who 2 years ago today was presiding over the presentation of items at the mission management team meeting, the first mission management team meeting of the final shuttle flight in shuttle program history, STS-135. Sakachi was the entry flight director during STS-135, so a bit of history repeating itself. Sakachi on console today in the overnight hours as a space station flight director. And inside the Quest airlock, Karen Nyberg on the left side of your screen, assisted by Russian cosmonauts Fyodor Yurchikhin and Pavel Vinogradov as they begin to install Safer unit number 1. He'll be wearing the suit bearing the red stripes in today's spacewalk, as he will again a week from today. Luca Parmitano is conducting the first spacewalk of his career. A good shot of him on the equipment lock wall, the innermost section of the Quest airlock, where he was suited up a few hours ago. He and Cassidy conducted in-suit light exercise protocol, basically the flexing of arms and legs to increase the metabolic rate and provide an opportunity to begin to set the stage for the pre-breathing of pure oxygen in their suits to cleanse nitrogen out of their bloodstreams and alleviate any condition known as the bends or decompression sickness from occurring at the time that they step out into the vacuum of space. Parmitano's spacewalk today, historic in nature for the European Space Agency. This first spacewalk of his career marks the first time an Italian astronaut will have walked in space, and the first spacewalk by a European Space Agency astronaut since Hans Schlegel performed a 6-hour, 45-minute spacewalk with Rex Walheim